We are going to solve a little bit more complicated trig function. There's just some algebra that we're going to have to do first before we start trying to find some angles. We are still going to solve for x in the restricted domain, so just one period worth from 0 to 2 pi. So if we look at the first problem, it says the 2 sine of x minus the square root of 3 equal to 0. So you're going to treat it as you would any other algebraic equation where you would add the square root of 3 to both sides, and then you would divide by 2. So now that we have done the algebra, we are trying to find out what angle or angles have a sine of the square root of 3 over 2. So remember, sine is positive in the first and the second quadrant, so we have two angles. Square root of 3 over 2 for sine has a reference angle of pi over 3. I folded down my my pointer finger. So I have pi over 3 is one of them, since it's the first quadrant. And I need to find the reference angle that's going to put pi over 3 into the second quadrant. That's going to be 2 pi over 3. So here are my two angles. All right, so one step here in B first before we can start figuring some angles. We just need to subtract 1 from both sides. In your normal domain of 0 to 2 pi, sine is only equal to -1 at one place, and that is at 3 pi over 2. One way I tend to look at it, if I kind of just remember my 3-point sine, I remember it's negative down here at that 3 pi over 2. So I just kind of actually use my 5-point reference from graphing sine and cosine to help me find out if they're angles on the axes. All right, so in C, we're going to first add 1 to both sides, and then we are going to divide by 2. So I am trying to find out when cosine is equal to 1/2. So cosine is positive in the first and fourth quadrant. So the 1/2 is just going to be the angle in the first quadrant. So if I use my fingers, I'm folding down the pointer finger. So I have a reference angle of pi over 3. So my first angle is pi over 3. And my second angle has a reference angle in the fourth quadrant. And that angle is going to be 5 pi over 3. All right, so if we have a situation in D, or similar to D, if we see that they're multiple, we have two factors, it follows your zero product property from going back to algebra. So if you have two factors equal to 0, set them both equal to 0 and solve them. So we're actually going to treat this as two different problems. We'll do the easier one first. Cosine of x equal to 1. That is one of your axes points. And if you think about your cosine graph starts up and you're 5 points for cosine. So it's going to be where we start up. So cosine of x is going to equal to 1 at 0. Now it technically would be pi over or 2 pi as well, but if you look at the top, we are including 0, but we're not including 2 pi. So I would not include that in my answer. So for the other part, I need to add the square root of x, sorry, the square root of 2 to both sides, and then divide by 2. So we're trying to find when we have the sine of the square root of 2 over 2. That has a reference angle of pi over 4, and sine is positive in the first and second quadrants. So we just have your normal pi over 4. And then we're going to go into the second quadrant, so we have a reference angle of pi over 4, and that's going to be at 3 pi over 4. So that would be how you would solve some more complicated ones. We can actually be a little bit more complicated in this fact that they're not as easily solvable, or they're not factored for us. So we're going to look at these two as the most complicated type that we'll see. And if you go back and remember your U substitution from the first thing that we did in the year, you will think of this problem as you see you have sine squared and sine of x. So if you made u sine of x, you have 2u squared minus u minus 3. And this might make it easier to go and factor. So you are trying to figure out what the factors are for a quadratic that has 2u squared minus u minus 3. So I'm going to have a 2u and a u. I need to add to -1. So I need a -3 and a +2. So we have 2u minus 3 equal to 0, and u plus 2 equal to 0.